This Chinese no-name 15,000 pound electric 12 volt winch. Guy I got this from, used, who claimed he'd never used it, but I'm gonna say that when he was setting it up, he probably just twisted that dang thing, probably just torqued it until it snapped, and he probably knew it and then boxed it back up and popped it on Marketplace, and I did a trade for something. I've got about $200 in it. Well, I soldered it, hoping that it doesn't, you know, melt the solder from the current. That's a real possibility. Never know. So the other day, I had to winch my road truck, my F-250, and a tag trailer loaded with log bunks with 1,000 board feet of wood on it. I had to winch it out with this skidder truck here. You see my winches on there. I actually busted, like I broke the frame of a 15.5 rated winch, which is a pretty big winch. I was being stupid. I wedged this truck up against a tree, and I was pulling into, at the time it was 11 o'clock at night, in the rain, in the dark. I couldn't really tell that I was really just wedging myself into something impossible, and I basically stalled the winch out. And what ended up happening was the plate that it's mounted to bent, and because one side of the winch tilted down, it actually snapped right there and right there. Just, you know, the two pieces differentiated. You can't blame the winch. It's not meant to take that kind of load. So my own fault for not having a better mount, more bracing on there, which was originally the plan. I mean, the plan was for this cross member to come out and another log bunk to go across, and the winch to be mounted under the log bunk with a lot of bracing. And it'll probably still happen, but I just hadn't got to it yet, and then I got in a bind, and I needed to get unstuck and before the truck froze in the mud. And so stuff happens, collateral damage. Here's the 4 holes for the winch. The whole plate kind of wallered, and I even straightened it out a little bit. Yeah, you can see it a little bit right there. You can see how it's got a little wave to it. So here's half of the winch that I popped. This is the half that I need to look into something. You can see I broke that hunk of casting out. That hunk there. Well, I didn't have to go very far. I did explode something. This little drive assembly piece. So this motor might be going on to a sawmill project or something like that. I'm telling you, this was an extreme abuse. Full power. Probably 400 or 500 amps. And the solder's still there. It didn't, I'm sure it got hot. It may have liquefied, but it didn't drip out. So we're out in my junkyard right here, looking at a machine that I built some time ago. There's an air tank, York 210 air compressor, snowblower chassis. So from here back, it's a snowblower. It's got garden tractor rims welded to the snowblower rims. So it's forward and reverse, self-propelled. It's got a 110 start button right there, which is nice. If it hasn't been running in a while, it's kind of a bear to get it running. I snapped off the pull rope and the tires went flat, and I haven't needed it in a while. Now, this is an alternator from a Nissan Frontier sitting in the backyard. And there's the pulley system. There's the shaft coming out of the snowblower. And all I've done is just sister up a 3 times bigger pulley and weld it on. So that overdrives. Now it's a 3,600 RPM engine. So wide open, it'll put about 10,000 RPM to that alternator. The issue with using this as a weldernator is that the field, you have to put, to get welding amounts of current, you have to put maximum voltage into the field. If you could put 50 volts in the field, you'd have a hell of a welder. I mean, it would overheat, but you'd have quite a lot of power on demand until something burned. When you've got a battery that is not being charged, it's being discharged, that battery is powering the field when you're trying to weld. So that battery is continually being drained. So when you start welding, your initial start is the highest, and then it just keeps tapering off in power until that battery goes dead, and then you've got to switch over and recharge it. So what we need is 2 charging systems. To run a weldinator, you need to have one alternator that just makes 14 something volts, and that feeds into the field of the second alternator, the high stage, that produces your welding current. Now, breaking that winch was probably one of the best things that happened to me. Let's go see why. Okay, so here's the meat and potatoes of this winch motor all apart. We got the mount that I broke that thing off there, but the base is still fine. The armature coupling is still fine, and it's very simple. It's not a spline, it's just a flat. I can make a coupler to that very easily. It's got high-speed bearings. It's got fat metal bars. That copper is not going to burn up. This is actually comparable to a big rig starter, and it's really, really robust windings. You don't find windings like that in an alternator. You want to make a welder out of an alternator, your windings are probably going to be the limit, because you can supercharge the thing. You can put a ton of voltage on the input side. You know, if you put two alternators kind of in series and crank the field to maximum output, you're gonna end up melting something, and it's gonna be a winding. You ain't gonna melt those windings. You'll light something else on fire before you do that. Same thing with the field inside there. Those are like copper bus bars. That's flat copper strip. Those are not wires. They're lugs. They're like terminal lugs. The brushes are big. Pretty good size wire. That's probably maybe the weak link in there. Maybe the output lug. Probably the wire. At any rate, this is a 4-pole series wound. Winch motors are 4-pole series wound. Right here, that's your field. Okay? Goes daisy chains like this. Comes back out. You got 4 poles. North, south, north, south. What gives these really high torque, let's look at this little sketch here. These outer flats, that is your field. This is what you're going to be, to make a welder or generator, you have to energize the field. So you have to put juice, you have to put current through these windings around this iron core. And that's going to make a magnetic field. There's going to be magnetic flux radiating through this thing. And then when the rotor, when that iron strip right there interrupts that magnetic field, it's going to generate a voltage. It's going to impart a voltage on that wire. And that wire is going to put a voltage on that little piano key on the commutator. Okay? Or this one, and it's going to go into the brush. It goes into the brush and it comes out the lug. So there's, on your brush holder basically represents the tapping point to get the juice out of your stator or rotor, whatever you want to call it. So I put a piece of copper there, but that's one terminal and that's the other. Now this is normally bonded to ground. It's bonded to the case. But so the case is one terminal and this lug is the other terminal. Just like an alternator, you got one lug and then anywhere on the case you can take for ground. But the brush holder is grounded to the case. I'm going to spin this, high-speed bearings, rigid mount, easy way to set this up on a swing mount to tension a belt. Super heavy body, lots of mass, and are able to absorb a lot of temperature. Heavy windings, big brushes. I'm sure I can find these on Amazon, you know, replacement brushes. Fairly robust brush holder. Pretty good size output lug. There's only one way to find out what I can light on fire in this process, and that's to do it. So when I get there, I'll let you know. Thanks for watching, and God bless.